Today we are covering trigonometry, SOHCAHTOA, and by the end of this video you'll be able to answer any question on it. I'm Josh from Strong Students, where my brother and I help ambitious GCSE students like yourself master English and maths. So, trigonometry. The first thing you need to understand is that we can only do SOHCAHTOA trigonometry with right-angled triangles. We can do trigonometry on triangles that don't have a right angle, but that is higher, and I'm going to make a separate video on that. So say we have this right-angled triangle here. We need to know how to label three sides. First side you need to be aware of is the opposite, and that is opposite the angle given in the question. The next side you need to know is the hypotenuse, which is the longest angle in a triangle. And the final side you need to know is the adjacent. This is the remaining side in a triangle. And why do we need to know them three sides? Because that is what makes up the fundamentals of SOHCAHTOA. And these kind of triangles, you can put them as, are what makes trigonometry trigonometry. Well, right-angled trigonometry, at least. Because if you've seen the speed, distance, time kind of equation and the triangle for that, you'll know how to use these triangles. But this line down here in the middle between them means we multiply, and this line going across means divide. So for example, if we want to find the opposite side of a right-angled triangle, we will do sine of the angle times by the hypotenuse. But this is going to make more sense as we dive into some examples. So if we look at this example on the left here, we've got a right angled triangle ABC, and it's telling us some details about this triangle. We need to find BC. I'm going to label this as X. So with trigonometry, we start labeling our sides. I personally only label two sides, so we can see which triangle we're going to use. If we label all three sides, this can be a bit confusing. So I'm going to label H as O, because that stands for the opposite, because it's opposite the angle. And the side we have left over, the 8.7, is the adjacent. So I'm going to put A up there. This side opposite the right angle is the hypotenuse, but as I just said, we're not going to label that side, because we don't need to use it in this question. So now that I've labelled O and A, we look at our three triangles, SO, CAH and TOA. Which one of these triangles do we use? Which triangle has both an O and an A? It is TOA. So we're going to use TOA in this case. We are finding X, which is the opposite, and how do we calculate the opposite? We do T times by A. T stands for tan, and it's tan of the angle, and we multiply that by the adjacent side, which is 8.7. I should have mentioned this previously, but the S stands for sine of the angle, the C stands for cos of the angle, and T stands for tan of the angle. These are the three trigonometric functions. This is what makes up trigonometry: sine, cos, and tan. And having put that in your calculator, hopefully you should get to three significant figures, 6.32. So 6.32 is your first answer. Okay, so have a look at this question, see if you can have a go, label the two sides you need, and dive into this question. Pause the video and come back once you've had a go at it. So we're finding X in this case. What side is X? It is the opposite. Good. 32 is the hypotenuse because it's opposite the right angle. The leftover side is the adjacent, but we don't label that because we don't need it in this question. So now we think, what triangle are we going to use? We're going to use SO. We're finding the opposite, so we're going to do sine 60 times by 32, and that will give us our answer. And having put that in the calculator, correct to three significant figures should be 27.7 centimeters. Okay, right, so trigonometry gets a little bit more difficult when we have to find the angle in a right angled triangle. So firstly, we label the sides just like usual that we have. We have the opposite and we have the adjacent in this case. So what triangle are we going to use? SOHCAHTOA. We're going to use TOA because that is what has O and A. So in this case, what are we finding? Well, we're actually finding tan of the angle. So tan x is opposite over adjacent, which is 5 over 12.5. But the problem is we don't want tan x, we just want x. So how do we get rid of tan? Well, we have to do the inverse of that function. The inverse of tan, if it was sine, we're finding sine of the angle, we'd do inverse of sine. If we were finding cos of the angle, we'd do the inverse of cos. And what I mean by the inverse is if you have a look at your calculator, hopefully above sine, cos and tan, you can see sine to the -1, cos to the -1, and tan to the power of -1. That means they are the inverse of sine, cos and tan. So if we're finding x in this case, we're going to do tan to the -1, 5 over 12.5. And you simply do that by pressing shift and then the trigonometric function. That will now appear as tan to the -1. You put 5 over 12.5, and this will give you 21.8 degrees to one decimal place. Okay, so if you haven't already gone and watched my Pythagoras video that I linked earlier, make sure you go and watch it now because this question here is a mixture of Pythagoras and trigonometry. So if you don't know how to do Pythagoras, it'll be very difficult to do this question. So we need to find CD. I've labelled that as X here, and the problem with this question is that we don't have enough information with that right triangle in order to find X. So we need to find BD first, which I've labelled Y, and we do that using Pythagoras. Can you remember Pythagoras theorem? A squared plus B squared equals C squared. So in this case, we have C and we have A, so we're actually going to have to do C squared minus A squared to find B squared. So we're going to have to do 16 squared minus 12 squared equals Y squared. Putting that in the calculator, 16 squared minus 12 squared. This is 112, and the square root of 112 gives you 4 root 7. So I've got 112 equals Y squared. So to find Y, we do the square root of both sides. Square root of 112. To a few decimal places, this is 10.583. At this stage, you want to leave your answer as long as possible. Leave as many decimals as possible because you don't want to make any rounding errors. If you round it too early, then it won't technically be a fully correct answer when we do later calculations. So now we have Y as 10.583. Well, we can now label that as the opposite, and the side we're finding is the hypotenuse. So we're going to do trigonometry now because this is also a right angle triangle. So SO is what we're going to use here because we've got the opposite and the hypotenuse. We've got the angle, we've got the opposite, we need to find the hypotenuse. So we're going to do the opposite divided by sine of the angle, which is 10.583 divided by sine 40. And that will give us our answer. And putting that in the calculator, you get 16.5 centimeters to 3 significant figures. Trigonometry done. You have now mastered trigonometry, 2D trigonometry, SOHCAHTOA, so well done to you. If you found this video useful, please feel free to drop a like down below and share it with a friend. Also, feel free to subscribe to the channel if you want to support mine and my brother's mission in helping ambitious students like yourself achieve the best possible grades that they can. Please comment down below what video you want me to make next, and feel free to check out some of our other videos on the channel if you want to keep on achieving your goals and getting better at GCSE maths and English. Thank you so much for watching, and I'll see you in the next one.